Hi everyone, welcome to Code Silica. I am starting a 150-day LeetCode interview challenge where we solve one interview question every single day using Java with clear and structured explanations. Today we will begin with one of the most popular and most frequently asked interview questions, to sum. Let us understand the problem first. You are given an integer array called nums and an integer target. Your task is to return the indices of the two numbers such that their sum equals the target. There are a few important constants. Exactly one solution exists. You cannot use the same element twice and you must return indices, not values. Let us look at a simple example. Suppose the array is 2, 7, 11, and 15 and the target is 9. Here 2 plus 7 equals 9, so we return their indices 0 and 1. Simple enough. Now let us think about how to solve this. When you see a problem like this in an interview, the first question you should ask yourself is, how can I find two numbers whose sum equals the target? The most straightforward idea is to try all possible pairs. The brute force approach works like this. For each number in the array, we try pairing it with every other number and check if their sum equals the target. In simple terms, pick the first number, try it with all remaining numbers, stop when the sum matches the target. This approach is correct, but let us analyze its performance. The brute force solution uses two nested loops, which gives us a time complexity of order of n square. This becomes very slow when the input size is large. In real interviews, this solution is usually not acceptable and the interviewer will expect you to optimize it. To optimize this problem, we need an important observation. If the current number is x, then to reach the target, we need another number equal to target minus x. And this value is called the complement. We can use a HashMap to solve this efficiently. The idea is simple. We traverse the array once. For each number, we compute its complement. We check if the complement already exists in the map. If it exists, we have found our answer. If it doesn't, we store the current number and its index in the map. This approach works because we only look at previous elements. We never use the same element twice. We find the solution in a single pass. This reduces the time complexity from order of n square to order of n. Let us walk through the same example again, where we have an array having elements 2, 7, 11, and 15, and the target value is 9. At index 0, the value is 2, the complement is 7. It is not in the map, so we store 2. At index 1, the value is 7. The complement is 2, which already exists in the map, so we return indices 0 and 1, and we are done. Now that we understand the logic clearly, let us switch to LeetCode and code the optimized solution in Java. Now let us walk through this Java code step by step and understand exactly how the optimized solution works. First, we create a hash map called map. In this map, the key represents the number from the array. The value represents the index of that number. This map will help us quickly check whether a required number already exists. Next, we iterate through the array using a for loop. We use index I so that we can return indices directly when we find the correct pair. For every element in the array, we calculate its complement. The complement is simply target minus the current number. If this complement exists in the map, then the current number and the complement together form the required sum. Now we check whether this complement exists in the map. If it exists, it means we have already seen that number earlier in the array. If the complement is found, we immediately return the indices. The index of the complement comes from the map and the index of the current number is I. This guarantees we return two different indices. We use each element only once. And if the complement is not found, we store the current number and its index in the map. Notice that we store the number after checking, not before. This is very important because it prevents using the same element twice. This process continues until we have find the solution. Since the problem guarantees exactly one solution, we will always return from the inside loop. At the end, we throw a runtime exception. This line will never actually execute for valid LeetCode inputs because the problem guarantees a solution. However, adding this makes the method complete and safe from a Java perspective. The most important interview point here are: we solve the problem in one pass, time complexity is order of n, space complexity is order of n, as HashMap allows constant time lookups. This is the optimal and expected solution in coding interviews. Now that we have understood the code, let us quickly summarize the time and space complexity and move on to interview tips. Let us analyze the complexity of this solution. Time complexity is order of n because we traverse the array only once. Space complexity is also order of n because we use a hash map. There are This is the optimal solution expected in interviews. Always explain the brute force approach first, then clearly explain why it is inefficient, and finally move to the optimized solution. If the interviewer asks for follow up, we can discuss sorting or two pointer approaches. That's it for day 1 of our lead code interview series. Tomorrow, we will solve best time to sell and buy stock. Another extremely popular interview question. If this video helped you, like the video and subscribe to Code Silica. See you tomorrow. Happy coding.